So with a level 7.2, we're going to be working a little more on inverse trig functions. And in this section, it's super important that we know both what quadrants we're working in and what the domain of our functions are and our inverse functions. And if you remember your basic SOHCAHTOA, that's going to really help you out when you're trying to find these mixtures of trig functions and inverse functions. So for finding the exact values, what we're saying is this is the sine of some angle on the inside. And we're saying this angle is the inverse tangent of 1/2. Well, if we solve this, we're saying the tangent of some angle is 1/2. We can draw a picture for this. And in fact, tangent's positive in the first quadrant or the third quadrant. So we're just going to assume that it's in the first. And we have this triangle here. Here's our angle. Our opposite side is 1. Our adjacent side is 2. So 1 squared plus 2 squared equals c squared, or c equals the square root of 5. So we're asked, what's the sine of that angle? Well, the sine of the angle is 1 over the square root of 5, or just root 5 over 5. Now, how we did that is we're pretending that this inside function is our angle. Anytime we're talking about an inverse trig function, it's talking about the angle measure. And then the outside function is saying, okay, what's the value we get back out? So let's try another one. Find the exact value of the cosine of inverse sine of -1/3. Again, this is our angle measure. So we're saying theta equals the inverse sine of -1/3, or sine of theta equals -1/3. Now, knowing that our domain for inverse sine is from -1 to 1, this also means first and fourth quadrants. So if we have a negative measure, our angle is going down from the origin and it's going to end in the fourth quadrant. So sine is, and this is our angle here, opposite over hypotenuse. So if we find this missing side, we have x squared plus 1 squared equals 9, c squared. So x squared equals 8, or x equals 2 root 2. Simplify that square root. We should know that by now. Okay, this is asking you, what is the cosine of our angle? So the cosine is adjacent over hypotenuse. Last one on this page. We want the tangent of inverse cosine of -1/3. Well, inverse cosine of -1/3 works because our domain is between -1 and 1. So if cosine's between -1 and 1, that means the first and second quadrant. So if this angle is negative, that means we are in the second quadrant. And our angle is right here because cosine is going to be adjacent over hypotenuse. We're saying theta equals inverse cosine of -1/3, or cosine of our angle is -1/3. That's how we got this. So again, that would be 2 root 2 to finish out this triangle. Same problem as this. And now we're asked, what's the tangent? So what's the tangent of our angle? So opposite over adjacent, so 2 root 2 over -1, or -2 square root 2. In each one of these, you could type it into your calculator and you will see that you get all of these values back out. So if we go over this process just one more time, we're using our basic geometry principles to draw our triangle, and then we are putting it in either the first, second, third, or fourth quadrant. Okay, let's flip it over. So with example 4, it seems like a really simple question. Find the exact value of the inverse cosecant of 2. So what we're saying is theta equals the inverse cosecant of 2. or the cosecant of theta equals 2. Well, this should be on the unit circle, and we should know where this is at. This is the same, cosecant is 1 over the sine of theta, which is equal to 2. So that means if we took the reciprocal here, we'd have the inverse sine is equal to 1/2. Well, if we know our unit circle, inverse sine is 1/2 at pi over 6. So theta equals pi over 6. This is an angle. This is what we're asking for. Now, on your calculator, you might be saying, well, why don't we just do this on a calculator? We could. If we have this trig button, some of you guys have this feature, others you have this blanked out. So inverse secant of 2, and I hit enter, is pi over 6. So if we said what we're doing, if you want a shortcut with reciprocal functions. Take the reciprocal function and reciprocal inside value. So if you do not have one of these fancy calculators and you want to figure out the inverse secant of 3, then we're going to say this is, well, I'll do it the long way one more time. So theta equals inverse secant of 3, or secant of theta equals 3, or 1 over cosine equals 3, or cosine 1/3. Now that's not on the unit circle, so theta equals inverse cosine of 1/3. So if we go to our calculator, and I'm going to just double check that all of my angle measures, we're going to be working in radians, which is perfectly fine for me. So we're going to hit trig, inverse of 1/3. And we get 1.231. And I'll just put our unit there, which is in radians. So if we have this similar process, the reciprocal, we are going to have inverse sine of the reciprocal of the inside. If we do that, that gives us our nice little trick. We can just do the inverse sine of -1 over 4, which is -0.253. And just to make a double check, I can hit this and go inverse secant of -4. And look, my calculator tells me, oh, it's just the negative inverse sine of 1/4. So let's try cotangent, reciprocal function, reciprocal number. So the tangent, inverse tangent of 2 is 1.107. And again, since mine works this way, I know some of yours does not, or if you have just a scientific calculator, inverse cotangent of 1 divided by 2. This is just as a proof. These are the exact same values. Last one, inverse cotangent of -2. So this is the tangent of -1/2. Flip reciprocal function, reciprocal value. So I'm just going to go back up here since I had it typed in. Hopefully this method makes sense to you guys. So -0.63, -0.464. These are all in radians. Make sure that we're answering the question with whatever unit we want, either degrees or in radians. For the most part, we've been working in radians, which has seemed to be working out fine for us. Okay, Bring any and all questions you have on this section to class. Next up will be the first part of Level 7 test. All right, good luck.